Right, so we've got an example of some trace tables here. What you have is an indexing that starts at 0. So each of these arrays, 0, 1, 2, 0, 1, 2. Always pay attention to this, because in some exam questions, I don't know why they do it, but some questions they sometimes start the index at 1. All right, but just be aware that that we're starting at 0 for this. So it says line numbers are included but not part of the algorithm. So basically, they're just there as a reference. Now it says here, complete the trace table for the following subroutine call. All right, authenticate. It's passed in user Alice and Woof 2006. So the user here is Alice, and her password was Woof 2006, just so you can see what's happening. All right, now we've got our usernames and we've got our passwords. That's what's happening here. Now Z is 0 and correct is false. Well, that's like our trigger, all right, if you like. It's like a flag, all right. While this is going to be used, all right, later on to check whether it's correct or not, okay? So it says while Z is less than 3, is Z less than 3?
Yes.
Okay, so what is the current value of Z?
0.
So what should we have put in our trace table?
0.
0. Remember, whenever something is assigned, so whenever I've got the arrow for an assignment, I need to write it down somewhere. So Z is 0, and correct is set to false. Generally speaking, those are outside the loop, okay? So those need to be declared before you go into the loop. So this is like the section outside the loop. Now we jump into the loop. Whenever there is an assignment, we need to change it. So Alice and Woof were put in, all right? So it says here, if user equals user Z, what's the value of Z at the moment? 0. Then pass is set to if user 0, all right, is that going to be correct? No, because look, user 0 is Dave. User 0 is Dave and user is Alice. So they're not the same. But if they are, all right, it's going to then check the password. So was it the same? No. So it doesn't even go into this to change it. So all that happens, because that condition wasn't met and that condition wasn't met, we don't even do this. So we just do Z is Z plus 1. All right. So Z is now set to 1. Okay. Now that that's set to 1, let's look at this. All right. So Z was set to 1. We've done that. Right. Is 1 less than 3?
Yeah.
All right. What's the value of Z of user is Alice? User 1 is Alice. So they're right. So that means we now jump into this one. Now, the value of Z is still 1. So, is pass with 2006 equal to PS 1? Yes, it is. So what happens to the value of correct? Goes up to true. Now this is the bit where a lot of people, all right, will just think, oh, it's found it now, therefore we stop. No, you've got to keep reading the algorithm. Don't just assume that it's going to stop, because the while loops condition is while z's less than 3. We need to check them all. All right. So what happens to the value of z? It goes up by 1, which is 2. All right. But obviously this time around, all right, nothing has set this to false. We're not going back up here, we're going in here. All right. So the value is now 2. Is Bob equal to Alice? No. So we go straight here and the value of z goes up. The value of correct hasn't changed. There's nowhere where it's been reset, so it's just left as it is. Unless the value changes, you leave it blank. All right, and then the value of z went up to 3. Is z less than 3? No, it's not less than 3 anymore, so it jumps to the return statement and the subroutine is finished. That is what's happening there, okay? Am I making sense?
Yeah.
So when it comes to trace tables, you only acknowledge when there is an assignment being changed, okay? Any questions on that?
It's not like you know how you write if you write true, then you don't need to write it again.
Yeah.
You can mark down if you write it again. Or
No, but I'm just saying you don't need to, writing is valuable time. Don't write something if it's not changing, yeah? So just for your own sanity, if it doesn't ever change again, you don't need to write it down. But you would need to obviously make sure at that column, if something happened there, all right, you just need to acknowledge where it happens, okay? Now it says, state the value returned by the following subroutine call. So if I put Bob in and ABF32. So if I put in Bob, all right, the answer, although it might match this one, okay, because, all right, eventually it would go through the whole list and it would find Bob, all right, in position 2. The second item, ABF32, wouldn't be true with this. So that if statement wouldn't happen. So therefore, it would remain on false. All right? It's just about learning when the assignment changes, okay? Now, the next question, it says, line 7 and 8 in the subroutine could be replaced with a single line. Shade 1 lozenge to show how you could do that. Well, that was just about adding. Remember, look, with nested if statements, what you've got to remember here is that it's 2 conditions. If that condition's met and that condition's met, this will happen, okay? So that's the best way to remember nested if statements are like an and. Because if that is met and that is met, that happens. So, to rewrite it, you would have written it as an and. So if you're ever kind of stuck, all right, the thing about nested if statements is they're basically about using an and operator. And then it says the programmer implements the subroutine and he replaces line 9 with return true. He also replaces line 14 with return false. So let me just show you that there. All right, so he's replacing line 9, all right, and line 14, all right. So that line 14 would say false, and that would now be true. He explained how the programmer has made it more efficient. All right. Well, basically what this means is the program will return true as soon as a match has made. So rather than having to actually go all the way down here and do these codes, right, it's going to return the value straight away. Okay, so that has made it more efficient because there's less lines of code to get to for the return because it does it right away. All right, so what that's saying there is program will return true as soon as a match is found. So that's one mark. But then your follow-up point is, so it means it doesn't need to keep iterating through the list of usernames. As soon as you return something, it stops you from having to keep going through that list, all right? going to continue on now. We have another trace table here, which passes in a value A and a value B. All right, C is the total of A and B. While A is less than C, add 1 to A, B is minus A. So you've got to think about what's going in. So over here, all right, the value of A is, if you have a look here, the value of A is 3 and the value of B is 4. All right. Before I even write it into this table, all right, I'm going to, well, actually, I'll tell you what, I'm going to start working that out, because that's an assignment there, isn't it? Yeah? If the values have been passed in here, okay, it is worth acknowledging it. All right? So the value has already been passed in, so 3 and 4. So even if it's passed into the subroutine, it's worth acknowledging it, all right, if there is space for it in your table. So I've got the value 3 and 4. So what is 3 and 4? The value is 7. Okay, now we jump into our loop. So remember what I said, the first bit is usually your setup before you go into the loop. That's like your pre-loop. Now we're in the loop. While A is less than C, A is A plus 1. What's A plus 1? 4. So this is inside the loop. B is B minus A. It is 0, okay? Because the value of A went up. Yeah? So that the value of A is now 4. So you include the value that was changed. The value of A was set. Don't get it twisted by think you subtract by 3. You've got to look at what it was assigned to, because that's the new value. So A was originally 3 plus 1. So A became 4. So B is 4 minus 4, which is 0. Okay? What happens to C?
Stays the same.
It stays the same. Alright? Now, is A less than C?
Yeah.
Yeah. So we're going to continue looping here. Alright? So, A is now A plus 1, which is 5. Alright? Now, B is 0 minus A, which is minus 5. Does the value of C change? No. Alright? The value of C is 7. Is the value of A less than 7? Yes. So the loop is going to continue. So A plus 1 is 6. Alright? And this time we've got minus 5 minus 6, which gets you to minus 11. Is the value of A still less than C?
Yeah.
Yes, it is. So now the value of A is A plus 1, which is 7. All right. Let's look at this again. B minus A, so minus 11 minus 7 is minus 18. That is your answer for that trace table there. Generally, the way they'll do the marks will vary from time to time. Sometimes this is a free marker. Sometimes they might give you a mark for that column being correct. Sometimes they might give you a mark for having the first row. There's usually a mark for having the first row correct, instantiating it, setting it up. All right. In this case, there's 1 mark for this column, 1 mark for this column, and 1 mark for this column. Okay. Now, a program mistakenly tries to shorten the subroutine by replacing the lines with C, A plus B. So replace that with while A is less than A plus B. Why is that a mistake? So while A is less than A plus B, why is it a mistake? What do we think? Yep.
Is it because the value of C doesn't change, but the value of A and B change, so when you add them together, that value changes.
That's exactly the answer there. Right? The whole point is I need to be able to exit this loop at some point, but the value of C was originally good because it never changed, so I could always compare it to that and keep it going while it was less. But the problem is the value of B and the value of A is always changing. So your answer here is the value of C is constant. All right. A plus B will always change, and also acknowledge it is a logic error. So you could have had any way to get the answer there. All right. Acknowledge that logic error. Okay. What is the value returned if we put x and 0? Is any positive what value is what value is returned when you put x 0, where x is any positive value? All right, so we have a look at that. All right, so x is any positive value and b is 0. We'll just try it out, okay? Because if I put in 0, right, b, let's have a look at that. So if I put in, say, 3 and 0 there, so if you want to, you can even create your own little, if you get stuck, you can create your own little trace table over here. So if I put in, say, 3 and 0, right, let's see what happens, all right? So C is 3 plus 0, which is 3, okay? While A is less than C. Yeah, good, you spotted that, all right? So sometimes it helps. So because it's the same, it doesn't do this. So it returns B, what's the value of B? Yeah, so let's put in another one. If I put in a 4 there, all right? Okay, so, and a 0. What is C? 4 plus 0, that's 4. Is the value less than C? No, it's the same. So I would return B, which is a 0. So you can see that the value would always be a 0. If it helps you, draw your own little trace tables to work out what's going on. A lot of those are only 1 marks, but they could be a difference to help you getting one of the top grades on this, okay? So it's just something to consider. We're going to do this trace table here, all right? So let's work our way through this one, which is worth 4 marks, all right? So let's start off. What is the value of A? Is the value n. So n is the value that's passed in, which was 50. So the value of A is 50. Value of B is 0. All right, nothing is output yet. We go into our loop. Repeat A div 2. All right, the value of n will not need to change ever again because it was just passed in the subroutine, okay? But what is A div 2? It is 25, okay? What is, all right, so then we've got, so B plus 1. What's B plus 1? Good. Any output? No, because it's while A is less than or equal to 1. Until, sorry, A is less than or equal to 1. So we're not there yet. Okay? So, let's go back. What is A div 2? 12. Remember, div is the floor division, okay? You don't do the negative. You don't do the decimal place. You just do the whole number. So you don't put 12.5, you'd put 12. Right? B plus 1 is 2. Is A less than or equal to 1? No, it's not. So now let's go back to A. A div 2. 6. Good. B plus 1. 3. Notice I'm only doing this whenever the arrow occurs. Right. Again, is A less than or equal to 1? No. Okay? So 6 divided by 2 is 3. Right? B goes up. A is still not less than or equal to 1. So we're still inside this loop. What's 3 div 2? 1. Good. Alright. What's B plus 1? 5. What's the value of A? 1. A is less than or equal to 1. Yes, it is. Okay? All right? So we now jump out of the loop. Generally speaking, what I like to do is when I come out of the loop, all right, anything inside of the loop, I kind of try and keep together in a loop, all right, iterating, and then I put the output on a new line, all right? So what would the output be? 5. Output of B. All right? So there's a one mark for this column. So 1 mark for, in fact, I'll just show you that. All right? 1 mark for the first value in column A and the first value in column B. So there's 1 mark for that. All right? 1 mark for correctly dividing the first. So 1 mark for this. Okay? 1 mark for the 6 values in column B. All right? And obviously a mark for your output. Look, ignore different rows used as long as the order of the columns is clear. So they're not going to be too nasty to you if you don't. If you put 5 there, they're not going to give you the mark as long as the order is correct. All right? They are going to give you some benefit of doubt. So don't freak out too much about that. It says state the value in the subroutine if you put number 1 in. Well, what you could do if you wanted to is put A and B at the side. This is the best way I answer these subroutine questions. All right. If they then change it up on you and say, well, try and change it to this value. If I put the value in of n, all right, as 1. Let me scribble that out. The value of n as 1. So I've got n as 1. A is equal to 1. B is equal to 0. Repeat, A div 2. What is A div 2? It would be 0. You're right. So that would be 0. But what is B plus 1? All right. But look what it says. Until A is less than or equal to 1. Well, is 0 less than or equal to 1?
Yeah.
Yeah. So what's the output? B, which is 1. So that's how you work that out. So your best technique for doing these trace tables is to draw a little bit of a table on the side when you need to work out what's happening. That's what I would personally do, and it's going to help you get those, 1 to 2 marks can be a huge difference to people, all right? I'll go through this one, and then I'm going to wrap things up, all right? And I can give you the mark scheme for the remainder of the questions so that you can practice those at home, okay? So, state the better identifier for this variable that makes the algorithm easier to read, all right? So we're going to look at C. So state the better identifier for the variable that makes it easier to read. And I will have, so we are on 3. You could have had total, could have had times, number of times, or even a counter. What it's getting at is you're acknowledging how many times you've done a repeat. If you can see in that algorithm that B is being used to kind of count how many times you've had to iterate through something, you've got to look at the purpose of the algorithm to write it in there. Does that help?
Yeah.
All right. So I will upload that video for you. I will upload that mark scheme, and we'll go from there.